You are listening to BDD Unveiled, building better software, step by step. Subscribe to keep up to date on our latest audiobooks. BDD Unveiled, building better software, step by step. Welcome to the world of BDD, beyond just testing. 1.1 The Software Development Conundrum. Imagine a bustling construction site. The architect has a clear vision, the structural engineer has designed the foundations, and the builder is ready with their crew. But what if the blueprint is vague, filled with ambiguous lines and missing dimensions? What if the client, the architect, and the builder all have slightly different interpretations of what a functional wall or a secure roof truly means? The result, more often than not, is not just delays and budget overruns, but a finished building that doesn't quite meet the client's needs, leading to costly demolition and rework. This scenario, unfortunately, is remarkably common in the world of software development. Despite sophisticated tools, highly skilled teams, and refined development methodologies, software projects frequently grapple with a fundamental challenge: miscommunication. We build elaborate systems, code lines upon lines of logic, and spend countless hours testing, only to discover at the 11th hour that what we delivered, while technically functional, isn't what the business truly needed. This lost in translation phenomenon is a silent killer of projects. Requirements are often captured in dense documents, fragmented conversations, or vague user stories. Each team member, the business analyst, the developer, the quality assurance tester, interprets these requirements through their own lens, potentially leading to divergent understandings. A developer might focus on technical elegance, a tester on edge cases, and a business analyst on high-level goals. Without a shared, precise understanding of desired behavior, the pathway from a brilliant idea to a working, valuable piece of software is fraught with peril. The cost of rework, bug discovery late in the cycle, and ultimately building the wrong thing can be astronomical, eroding client trust and team morale. We once encountered a team building an e-commerce platform. Their requirement for the search function was simply users should be able to search for products. The developers implemented a lightning-fast keyword search. The business stakeholders, however, envisioned a search that understood synonyms, offered auto-completion, and allowed filtering by category and price. Both interpretations were technically valid based on the vague requirement. The result? Weeks of rework, frustration, and a missed market opportunity because the delivered product didn't align with the actual business need. 1.2 Introducing Behavior-Driven Development, BDD, a paradigm shift. Enter Behavior-Driven Development, or BDD. If the problem is miscommunication, BDD offers a powerful solution: a shift in perspective. It's not just a testing technique, nor is it merely a specific tool or framework. BDD is fundamentally a collaborative approach that bridges the communication gap between business stakeholders and technical teams. Its core promise is to transform ambiguous requirements into clear, explicit, and executable specifications, ensuring everyone is on the same page from the outset. BDD emerged from the test-driven development (TDD) movement, evolving beyond testing individual code units to focusing on the behavior of the system from a user's perspective. While TDD asks, "How do I build this code correctly?" BDD asks, "What behavior should this system exhibit, and how do I know when it's done correctly?" This subtle but crucial shift ensures that every line of code contributes directly to a desired business outcome. At its heart, BDD guides teams to define the behavior of the software in a common, understandable language. This language serves as a shared source of truth, becoming the foundation for conversations, development, and automated checks. It forces clarity, encourages collaboration, and ultimately helps teams build higher quality software that truly meets the needs of its users. 1.3 The Power of Communication. Ubiquitous language. One of BDD's most profound contributions is its emphasis on a ubiquitous language. Coined by Eric Evans in his seminal work on domain-driven design, ubiquitous language refers to a common vocabulary and understanding shared by everyone involved in a software project, from business leaders and product owners to developers and quality assurance specialists. Think of it as having everyone on the construction site, from the client to the bricklayer, agree on what foundation or load-bearing wall exactly means. In software, this means using the same terms for concepts like customer, product, order, or payment status. When discussions, requirements, and even the software's code all use the same terminology consistently, misunderstandings shrink dramatically. BDD actively helps establish and enforce this ubiquitous language. By articulating behaviors in plain, business-oriented language, it compels teams to clarify terminology, resolve ambiguities, and ensure that definitions are precise and shared. This collective understanding minimizes confusion, streamlines development, and reduces the likelihood of building features based on differing interpretations. Practically, a team adopting BDD might start by creating a simple glossary of key domain terms, regularly refining it as their understanding evolves. 1.4 The Three Amigos, the heart of BDD collaboration. Driving this collaborative discussion is a core BDD concept known as the Three Amigos. This isn't a fixed set of job titles, but rather a representation of the key perspectives essential for defining clear software behavior. The business amigo, this individual, often a product owner, business analyst, or subject matter expert, represents the why. They understand the business problem, the desired value, and the user's needs. Their role is to articulate the problem and help validate the proposed solution. The developer amigo, this individual represents the how. They understand the technical feasibility, potential architectural implications, and how to implement the desired behavior. Their role is to translate the business need into technical components. The tester quality assurance amigo, this individual represents the what if. They think about different scenarios, edge cases, error conditions, and how to verify that the system truly behaves as expected. Their role is to ensure testability and completeness. The magic happens when these three perspectives come together in conversation before any code is written. These Three Amigos sessions, often called discovery workshops or example mapping, are where raw ideas are refined into concrete, executable examples of behavior. Each amigo contributes their unique insights, collectively surfacing assumptions, uncovering ambiguities, and clarifying the true desired outcome. Consider a previous team that struggled with defining how a new guest checkout feature should work. Initially, the business amigo presented a vague user story. During their first Three Amigos session, the developer amigo immediately asked about payment gateway integrations and security. The tester amigo probed about what should happen if a guest tried to use a discount code for registered users only, or if their internet connection dropped during the process. These discussions, happening proactively, led to a much richer and more robust set of examples and scenarios, preventing costly surprises during development and testing. This collaborative process ensures that business value, technical viability, and comprehensive testing are all considered from the very beginning, leading to software that is not only functional, but also aligned with true business needs. 1.5 What you'll learn in this book. This book is your step-by-step guide to understanding and implementing behavior-driven development. We will embark on a journey that takes you from the foundational concepts to practical application, equipping you with the knowledge and strategies to transform how your teams build software. In the upcoming chapters, you will discover the simple yet powerful structure of given, when, then, and how it forms the universally understood language of BDD. The art of crafting effective scenarios, ensuring they are clear, concise, and executable. How to bridge the gap from human conversations to automated verification, making your specifications living documentation. Practical strategies for implementing BDD within your agile workflows and fostering meaningful collaboration. Insights into common pitfalls and how to gracefully avoid them, ensuring your BDD journey is a success. Techniques for scaling BDD beyond a single team, fostering consistency across larger organizations. The crucial human element in BDD. Cultivating a culture of communication, trust, and continuous improvement. Your journey will empower you to guide your team towards building software that truly matters, aligning everyone on shared behaviors, and ultimately delivering greater value. Let's begin. The core of BDD, understanding given, when, then. 2.1 The simple yet powerful structure. At the heart of behavior-driven development lies a deceptively simple, yet incredibly powerful linguistic construct known as given, when, then. This structure provides a clear, consistent, and universally understandable way to describe how a system should behave in response to a specific action. Its elegance lies in its natural language readability, making it accessible not only to technical teams, but also to business stakeholders who may not be familiar with software development jargon. This format is often written using a language called Gherkin. While Gherkin might sound like a technical term, it's really just a set of grammar rules that allows you to write executable specifications in a human-readable way. It's designed to be unambiguous and easy to parse by automation tools, but crucially, it's designed to be written and read by people first. Think of it as telling a story about a specific interaction with the system. Given. What is the initial state of the world? The setup, the preconditions. When, what single event or action takes place? The trigger, the interaction. Then, what is the expected outcome or result of that action? The consequence, the observable chain. This narrative flow guides your thought process, ensuring you've considered the necessary context, the specific action, and the verifiable result. 2.2 Given. Setting the scene preconditions. The given clause establishes the necessary context or preconditions for the scenario to occur. It describes the state the system or the environment should be in before the action, when, takes place. Imagine it as setting the stage for a play. Purpose of given: to define the initial state, to specify any existing data or user roles, to provide necessary background information without describing actions. Examples: given a user is logged into their account, establishes user status. Given the shopping cart contains laptop, sets up existing data. Given the product Cool widget is in stock with 10 units, describes inventory state. Given the user's account balance is $100, defines a financial precondition. Given the system date is 2024 to 1 to 15, sets an environmental context. Common mistakes with given, including actions. Given the user logs in is an action which belongs in when. A given should just describe the state after an action has occurred, e.g., given the user is logged in. Describing outcomes. Given the product is added to cart, this is an outcome belonging in then. Too much detail. Don't include information that isn't directly relevant to the scenario's behavior. 2.3 When. The action or event trigger. The when clause describes the specific action or event that triggers the behavior being tested. This should be a single, observable action performed by the user or the system under test. It's the moment the story's plot begins to unfold. Purpose of when: to define the single, distinct action or event, to represent a user interaction or a system event. Examples: when the user clicks Add to Cart, a user interaction. When the payment is processed successfully, a system event. When the administrator approves the request, an action by another actor. When the order is shipped, a system state change or event. When the system sends a nightly report, time-based automated action. Common mistakes with when: multiple, unrelated actions. When the user logs in and then clicks Profile, each one should ideally describe one atomic action that directly leads to the then outcome. If multiple actions are involved in one user flow, consider breaking it into multiple scenarios or using the AND keyword, discussed next, for closely related steps within one action. Describing consequences. When the product appears in the cart, this is a consequence belonging in then. Vague actions. When something happens, be specific about the trigger. 2.4 Then. The expected outcome post-conditions. The then clause specifies the observable, measurable result, or outcome, that is expected after the when action has occurred within the given context. This crucial part defines what success looks like from a business perspective. It's the resolution of the story. Purpose of then: to describe the verifiable changes in the system's state or behavior. To articulate the expected consequences of the when action. To confirm that the system correctly fulfills the business requirement. Examples: then the item should appear in the shopping cart, verifiable change in UI data. Then the order status should be shipped, verifiable change in system state. Then an email notification should be sent to the user, verifiable system behavior. Then the account balance should be $50, a specific data value. Then the user should see an error message, invalid credentials, a specific message displayed. Common mistakes with then. Describing implementation details. Then the database table orders should be updated focus on observable behavior e.g. Then the order status should be confirmed, not internal system mechanics. Being too vague. Then it works, be precise about how it works or what specific change occurred. Adding new actions. Then the user logs out, this is a new action, not an outcome of the previous one. 2.5 Enhancing scenarios. And but. While given, when, then form the core, BDD also provides and but keywords to add further clarity and detail without overly complicating the structure. And. Used to combine multiple given conditions, when actions, if very closely related and atomic, though generally one when is preferred, or then outcomes. It helps list multiple related items under one main GWT statement. Example with and, given a user is logged, and they have a valid credit card on file, multiple preconditions. When they purchase Cool Widget, then their order status should be confirmed, and their account balance should decrease, multiple outcomes. But used to express a negative outcome or a condition that should not occur. It's essentially a negative and. Example with but, given the user is on the login page, when they enter an incorrect password, then they should see an error message, invalid password, but they should not be logged in negative outcome. Using and but correctly helps to keep scenarios concise and focused, grouping related information logically. 2.6 Anatomy of a good scenario, a walkthrough. Let's put it all together with a simple, illustrative scenario for an online shopping cart. Feature, shopping cart functionality. This describes a high-level capability of the system. Scenario, adding a product to an empty cart. This is a specific example of the feature's behavior. Given the user is on the product page, for example lamp, and their shopping cart is empty, when they click the Add to Cart button, then example lamp should be added to their shopping cart, and the cart icon should display one item, and the total price should be $30.99. Let's break down each line. Given the user is on the product page for example lamp, this sets the initial context. The user is in a specific place in the application, browsing a particular product, and their shopping cart is empty. This adds another precondition vital for this specific scenario. If the cart wasn't empty, the outcome might be different, e.g., increasing quantity. When they click the Add to Cart button, this is the single, clear action that the user performs, triggering the system's behavior. Then, example lamp should be added to their shopping cart. This is the first expected outcome, the core behavior of adding the item. It's observable and business-focused. And the cart icon should display one item, a secondary, yet important, visual confirmation of the first outcome, and the total price should be $30.99, a further observable and measurable outcome confirming the correct pricing. Notice how this scenario is clear and readable. Anyone, technical or not, can understand what's being described. Concise, no unnecessary words or jargon. Focused, it describes a single, distinct behavior. Observable, all then statements refer to things that can be seen, heard, or otherwise verified externally. Unambiguous, there's little room for misinterpretation of what added to cart or display one item means. 2.7 Why start here? The foundation of shared understanding. The given, when, then structure is more than just a syntax. It's a powerful framework for thought. It forces clarity and promotes alignment. By meticulously defining the given context, the when trigger, and the then outcome, teams are compelled to clarify assumptions. What do we assume is true before an action happens? Surfacing these assumptions prevents hidden requirements or misunderstandings late in the development cycle. Define scope. What single action are we truly interested in testing? This helps to keep scenarios focused and manageable. Specify outcomes. What does successful completion look like? This ensures that the team builds precisely what the business expects, not just what is technically possible. Align understanding. When business analysts, developers, and testers all read and agree on the same GWT statements, they build a shared mental model of the system's desired behavior. This shared foundation is invaluable, bridging the communication gap and laying the groundwork for developing high-quality software that truly delivers value. Mastering this fundamental structure is the first, crucial step toward unlocking the full potential of BDD. With this foundation in place, we can now explore how to craft even more powerful and collaborative scenarios. Crafting powerful scenarios, the art of collaboration. 3.1 Beyond the syntax, what makes a good scenario? In the previous chapter, we dissected the given, when, then syntax, understanding the grammatical structure of BDD scenarios. But knowing the grammar isn't enough to write compelling prose or build truly effective software. A good scenario transcends mere syntax. It is a collaborative artifact that effectively communicates intent, clarifies behavior, and serves as a living specification for the system. So, what elevates a scenario from merely syntactically correct to genuinely powerful? Readability for all. The scenario should be easily understood by everyone on the team, regardless of their technical background. This means avoiding jargon, acronyms, and implementation details. It should tell a story in plain business language. Unambiguous, each phrase and word should have a single, clear meaning. There should be no room for differing interpretations between team members. Concise and focused. A scenario should describe one distinct behavior and be as brief as possible without sacrificing clarity. Avoid overly long scenarios that try to do too much. Customer-centric. Good scenarios describe behavior from the perspective of the user or a key stakeholder, focusing on the value they receive or the problem being solved. Verifiable and measurable. The then clauses must describe outcomes that can be observed and confirmed. You should be able to look at the system and definitively say whether the scenario passed or failed. Declarative, not imperative. Scenarios should describe what the system should do, not how it should do it. For example, when the user submits the form, declarative is better than when the user clicks the Submit button on the order page, populates field X and then field Y, imperative. The how is for the developers to implement. The what is for everyone to agree upon. To ensure scenarios embody these qualities, their creation is not a solitary task. It is the art of collaboration, facilitated through specific workshops and techniques. 3.2 Discovery workshops and example mapping. The best scenarios are not written in isolation. They are discovered through active conversation. This is where the three amigos truly shine. These collaborative sessions are often called discovery workshops or example mapping sessions. Example mapping is a particularly effective technique for structuring these conversations and ensuring a shared understanding of a feature. It uses distinct elements, often represented by different colored sticky notes, to visualize and break down a particular story or requirement. The story rule, often yellow or green. At the top, you place the user story or high-level requirement that you're discussing, often phrased as a business rule. For instance, customers get a 10% discount on orders over $100. Examples, often blue. For each rule, you generate concrete examples of its behavior. These are your given, when, then scenarios. For the discount rule, an example might be, given a customer has $120 in their cart. When they proceed to checkout, then their total should be $108. Questions often pink or orange. As examples are discussed, ambiguities, edge cases, and missing information inevitably arise. These are captured as questions. For the discount rule, questions might include, what if the customer only has $99 in their cart? Does the discount apply to shipping costs? What if they apply a different coupon? Implicit assumptions, outcomes, optional, different color. Sometimes there are things that are just understood or are direct consequences not needing a full scenario. These can be noted. How it works. The three amigos sit together or remotely using virtual whiteboards. They pick a story or rule. They discuss it, generating examples for how it should behave. As they discuss examples, questions naturally emerge. These questions are critical as they highlight areas of misunderstanding or missing requirements. Each question needs to be answered by the product owner or business representative, potentially leading to new examples, new rules, or a decision to defer a particular scope. Anecdote. A development team was about to build a loyalty point system. They had a general idea of how points would accrue. During an example mapping session, the developer asked, What happens if a customer returns an item they earned points on? The tester added. And what if they used points to purchase that item? These questions, initially unforeseen by the product owner, exposed critical business rules that needed to be defined. Without this collaborative discovery, these edge cases would likely have surfaced as defects much later in the development cycle, causing significant rework and frustration. Example mapping ensures everyone leaves the session with a shared, concrete understanding of the feature's expected behavior, captured as clear scenarios. 3.3 Diving deeper. Features and backgrounds. To organize your scenarios effectively and improve readability, BDD introduces two more important concepts: feature and background. Feature. A feature represents a high-level capability or a distinct area of functionality within your system. It acts as a container for related scenarios, typically aligning with a user story or a major business area. Each feature file, often named feature-rename feature, starts with a clear, concise description of the feature's goal and its business value. Example feature structure. Feature. User registration. As a new user, I want to be able to register an account so that I can access personalized features and services. Description. This feature covers the process of a new user signing up, including handling valid and invalid inputs, and ensuring a smooth onboarding experience. Scenario. Successful user registration. Given I am on the registration page, when I fill in valid registration details, and I click the Register button, then my account should be created successfully, and I should be redirected to the dashboard, and I should receive a welcome email. Background. Often, multiple scenarios within a feature require the same initial setup or preconditions. Instead of repeating these given steps in every scenario, you can use a background block. A background is executed before each scenario in that feature file. It's a way to define common steps as a prerequisite for all scenarios in a feature. Example with background. Feature. Order management. As a registered user, I want to view and manage my past orders so that I can track my purchases and resolve issues. Background. Given I am logged in as a registered user, and I have placed at least one order previously. Scenario. View list of past orders. When I navigate to the My Orders section, then I should see a list of my past orders, and each order should display its date, total, and status. Scenario. View details of a specific order. Given an order with ID ORD123 exists in my order history. When I click on order with ID ORD123, then I should see the detailed information for ORD123, and it should include shipping address and individual items. In this example, given I am logged in as a registered user, and I have placed at least one order previously, don't need to be repeated for every scenario in the order management feature, making the scenarios themselves more concise and readable. 3.4 Scenario outlines. Testing multiple datasets. Sometimes, you have multiple scenarios that follow the exact same pattern, but differ only in the data they use. Instead of writing separate scenarios for each dataset, BDD provides scenario outline with examples tables. This is incredibly powerful for data-driven testing and ensures thorough coverage without tedious duplication. Scenario outline describes a template for a scenario using placeholders angle brackets for the varying data. Examples: a table beneath the scenario outline that provides the specific data values for each placeholder. Each row in the examples table effectively generates a new scenario. Example scenario outline. Feature. User authentication. Scenario outline. User login with different credentials. Given I am on the login page, when I enter username, and password, and I click the login button, then I should see the message, expected message. Examples: username, password, expected message. Valid user, correct, welcome, valid user. Invalid user, wrong, invalid credentials. Empty surname, any username cannot be empty. Locked user, correct, account locked. This single scenario outline will be executed 4 times, once for each row in the examples table. This significantly reduces duplication and improves maintainability while ensuring a wide range of test cases are covered. 3.5 The living documentation principle. One of the most compelling benefits of well-crafted BDD scenarios is that they become living documentation. Unlike traditional documentation, which often becomes outdated the moment it's written. BDD scenarios are directly linked to the executable code. If the software changes, the scenarios and their automated tests will either pass or fail, always reflecting the current behavior of the system. This has profound implications. Always up to date, the documentation is literally the test suite. If the tests pass, the documentation is accurate. Single source of truth. Business and technical teams refer to the same set of scenarios to understand behavior. Faster onboarding. New team members can quickly grasp the system's functionality by reading the human-readable feature files. Reduced documentation effort. Teams no longer need to maintain separate specification documents that invariably drift out of sync with the code. Shared understanding. The scenarios provide a consistent and agreed-upon definition of done for any given feature. This living aspect ensures that the business analysis, development, and testing efforts are always aligned with the current, verifiable behavior of the software. 3.6 Common pitfalls in scenario writing and how to avoid them. Even with a full understanding of the syntax and structure, it's easy to fall into traps when writing scenarios. Awareness is the first step to avoidance. Too many steps in a scenario. If a scenario has a lengthy list of given, when, or then statements, it might be trying to test too many things at once. Each scenario should ideally describe one clear behavior. If it's becoming long, consider breaking it down into smaller, more focused scenarios or using background for common setup steps. Technical details leaking in. Scenarios should avoid mentioning UI elements, e.g., click button with ID, submit BTN, or internal system details, e.g., database table users should be updated. Focus on the business outcome and observable behavior. Replace click the submit button with when I submit the form, focusing on UI clicks instead of business outcomes. BDD is about behavior, not simply UI automation. While some UI interactions are triggers, the then statements should describe the system's response in business terms, not just UI element changes. Vague or ambiguous language. Words like should work, correctly, or as expected are red flags. Be specific. Then the user should see a confirmation message is better than then the confirmation works. Overspecification, imperative versus declarative. Telling the system how to achieve a behavior, e.g., specific navigation steps, rather than what the behavior is. A good scenario is a contract of behavior, not a script for execution. Lack of collaboration. Writing scenarios alone, without the input of the three amigos, almost guarantees missed perspectives and misunderstandings. Practical application. A quick scenario review checklist. Is it a conversation starter, collaboratively created? Is it human-readable, no jargon? Is it unambiguous, one interpretation? Does it describe a single, distinct behavior? Is it declarative, what, not how? Are the outcomes verifiable? Is it concise and to the point? By embracing these principles and actively collaborating in their creation, your BDD scenarios will become truly powerful assets, driving clear communication and ensuring the development of high-quality software that meets genuine business needs. Now that we understand how to write these powerful scenarios, the next step is to explore how these human-readable descriptions seamlessly transform into executable, automated tests. From conversations to code. Empowering automation. 4.1 The Bridge to Automation. Step definitions. We've established that BDD scenarios, written in the given, when, then format, are powerful tools for communication and collaboration. They effectively capture desired behavior in a human-readable format. But how do these plain language statements magically become executable tests that can verify the software's functionality? The answer lies in what BDD frameworks call step definitions. Think of step definitions as the crucial bridge between two worlds: the expressive, business-oriented language of your Gherkin scenarios and the highly specific, technical world of your software's code. For every given, when, or then line in your scenario, there needs to be a corresponding piece of code. A step definition that tells the automation framework how to perform or verify that particular step. Here's the conceptual breakdown, without delving into programming language specifics. When a BDD automation tool, which we'll discuss shortly, reads a Gherkin scenario, it parses each line, given the user is logged in when they click Add to Cart, etc. For each of these lines, the tool looks for a matching step definition. A step definition is essentially a small block of code designed to execute the action or verify the state described in the gherkin step. For example, if your scenario has the line, given the user is logged, your development team would write a corresponding step definition that might do something like: navigate to a login page, enter a predefined username and password into the login fields, click the login button, verify that the user is now on the dashboard or a logged-in state. Notice that the single line given the user is logged in encapsulates a series of technical actions. This abstraction is key. Business users only care about the high-level behavior, while the developers and QA engineers write the precise code needed to achieve that behavior. This separation allows scenarios to remain readable and stable, even if the underlying technical implementation changes. As long as the behavior described by the step remains the same, the gherkin line doesn't need to change, only the step definition code. 4.2 Introduction to BDD Automation Frameworks, No Code. To make the leap from human-readable gherkin to executable tests, we rely on specialized BDD automation frameworks. These tools don't write your code for you, but they provide the infrastructure to link your feature files with your step definitions and run them as automated tests. Some of the most popular BDD automation frameworks include Cucumber, a widely adopted tool originally built for Ruby, but now supporting many programming languages, Java, JavaScript, Net, etc., through various implementations. SpecFlow, the net equivalent of Cucumber, specifically designed for C# projects. Behave, a popular BDD framework for Python. JBehave, another pioneering BDD framework for Java. While each of these tools has its own nuances and integrates with different programming ecosystems, their conceptual role is the same. Parse Gherkin. They read and understand your feature files, interpreting the feature, scenario, given, when, then, and, but, scenario outline, examples, keywords. Match steps to definitions. They maintain a registry or mapping between the gherkin phrases in your scenarios and the corresponding step definition code you've written. Execute step definitions. When a scenario is run, the framework executes the linked code for each gherkin step. Report results. After execution, the framework provides a clear report indicating which scenarios passed and which failed, along with details for any failures. It's crucial to understand that these frameworks are tools to facilitate BDD, not BDD itself. The BDD mindset, the collaboration, the shared understanding, the focus on behavior, precedes the choice and implementation of any automation tool. A team can practice BDD without automated gherkin scenarios, e.g., through manual exploration and conversation. But automation scales the benefits significantly. The tool is simply the vehicle for delivering the living documentation. 4.3 The Cycle of Automation. Red, green, refactor for BDD. For developers, BDD introduces a powerful, iterative cycle that guides development and ensures that new features meet their acceptance criteria. This cycle mirrors the classic red, green, refactor approach from test-driven development, TDD, but applied at a higher behavioral level. Here's how the BDD automation cycle typically unfolds. Red, write a failing scenario. Based on the collaborative discussions, Three Amigos, example mapping, a new scenario is written in Gherkin. This scenario describes a yet-to-be-implemented feature or a new aspect of behavior. When this new scenario is run through the automation framework, it will fail or be marked as pending because its step definitions don't exist yet. This is expected and desired. It confirms that the feature isn't working as described yet. The failing scenario becomes the concrete definition of done for this specific behavior. Green, implement, and pass. The development team then writes the necessary step definitions and the underlying application code to make the failing scenario pass. They work iteratively, often running the scenario repeatedly, until all the steps execute successfully and the expected outcome is achieved. The passing scenario indicates that the desired behavior has been implemented according to the shared understanding. Refactor, clean up, and improve. Once the scenario passes, the developers refactor their code, both the step definitions and the application code. This means improving the internal structure, readability, and performance of the code without changing its external behavior. The passing BDD scenario acts as a safety net. If refactoring breaks anything, the scenario will immediately fail, signaling a problem. This confidence allows developers to continually improve their codebase without fear of introducing regressions. This continuous loop provides rapid feedback, ensuring that developers are always building precisely what is needed, and that newly implemented features maintain the integrity of existing functionality. 4.4 BDD and Test Automation Strategy. It's important to understand where BDD scenarios fit within an overall test automation strategy. They are not a replacement for other forms of testing, but rather an enhancement that provides specific value at a particular level. Think of the test automation pyramid. Bottom, unit tests. These are small, fast, isolated tests written by developers to verify individual functions or classes of code. They focus on internal implementation details. BDD scenarios do not replace unit tests. They operate at a different level. Middle integration tests. These tests verify that different components or services of the system interact correctly with each other. They might test API integrations or database interactions. Top acceptance end-to-end tests. This is where BDD scenarios primarily reside. They focus on testing the system from an outside-in, business user perspective. They verify that the complete user journey or a critical business flow works as expected across multiple system components. BDD automation focuses on the top of this pyramid. It's about validating business behaviors and user journeys, ensuring that the software delivers the expected value. While BDD can drive lower-level tests, its greatest strength lies in defining and verifying acceptance criteria. Practical application. When deciding what to automate with BDD, prioritize core business flows, the most critical paths a user takes through your system. High-value features. Functionality that directly drives revenue or user satisfaction. Regression coverage. Features that, if broken, would have significant impact, ensuring they continue to work correctly after changes. Complex scenarios edge cases. Behaviors that are prone to misinterpretation or bugs. 4.5 The benefits of executable specifications. When BDD scenarios are automated and integrated into your development pipeline, they transform from mere documentation into executable specifications. This brings a host of powerful benefits. Automated regression suite. Every passing BDD scenario becomes a living, automated test. As you add new features or refactor existing code, you can quickly run the entire suite to ensure that previous functionality hasn't been broken, no regressions. This builds immense confidence in your deployments. Faster feedback loops. Automated scenarios can be run continuously, e.g., as part of your continuous integration, continuous delivery, CI/CD pipeline. Developers get immediate feedback on whether their changes introduce defects or broke existing behavior, allowing them to fix issues quickly when they are cheapest to resolve. Ensuring behavior matches intent. Automated scenarios provide an objective, undeniable confirmation that the software actually behaves according to the shared understanding captured in the gherkin. This eliminates subjective interpretations and manual, time-consuming verification. Continuous documentation. Because the tests are the documentation and they are continuously run, you always have an up-to-date representation of your system's behavior. This is invaluable for onboarding new team members and understanding past decisions. 4.6 Challenges in automation. While powerful, automating BDD scenarios isn't without its challenges. Maintaining step definitions. As the application evolves, step definitions might need updates. Poorly written, fragile, or highly coupled step definitions can lead to brittle tests that break with minor UI or backend changes, requiring significant maintenance effort. Dealing with complex UI interactions. While BDD focuses on behavior, some scenarios necessarily involve UI interactions. Automating these can be complex, especially with dynamic web pages or intricate user interfaces. It's crucial not to let the technical challenges of UI automation dictate the BDD scenario's clarity or focus on behavior. The risk of brittle tests. If step definitions are not designed with care, e.g., using unstable selectors, hard-coding data, tests can become prone to failure even when the underlying functionality is correct. This leads to flaky tests that erode trust in the automation suite. Performance overhead. Running high-level, end-to-end BDD scenarios can be slower than unit tests. While they provide comprehensive coverage, a massive suite can slow down feedback if not managed efficiently. To mitigate these challenges, teams must prioritize well-designed, robust, and maintainable step definition code. The goal is to build an automation layer that supports the BDD process, not one that becomes a bottleneck. By effectively bridging the gap from conversational scenarios to automated tests, BDD empowers teams with fast feedback, living documentation, and a clear, verifiable understanding of their system's behavior. This integration is crucial for building high-quality software efficiently and with confidence. BDD in action. Strategies for successful implementation. Having explored the foundational concepts of BDD, its collaborative spirit, the given, when, then structure, and the bridge to automation, it's time to shift our focus to putting BDD into practice. Implementing BDD isn't just about learning a new syntax or tool. It's about integrating a new way of working into your existing development processes. This chapter provides practical strategies for introducing BDD effectively and maximizing its benefits. 5.1. Integrating BDD into Agile workflows. BDD is a natural fit for Agile methodologies like Scrum and Kanban. Its emphasis on collaboration, iterative development, and rapid feedback loops aligns perfectly with Agile principles. The key is to weave BDD activities seamlessly into your existing ceremonies and practices. During sprint planning/story refinement, this is arguably the most crucial point for BDD. Instead of merely listing requirements, the product owner, developers, and testers, the three amigos, collaborate to define concrete examples, scenarios for each user story. These discussions, often facilitated by example mapping, clarify ambiguities before development begins. The acceptance criteria for a user story effectively become its BDD scenarios. Throughout development sprints, once scenarios are defined, developers use them as executable specifications. They write code and associated automated step definitions with the explicit goal of making these scenarios pass. Testers can use the scenarios to guide their exploratory testing and provide early feedback. During daily stand-ups, teams can discuss progress in terms of scenarios, how many are defined, how many are passing, and what roadblocks exist to implementing the next behavior. During sprint review/demo, the passing BDD scenarios can demonstrate the implemented features to stakeholders, proving that the software behaves as expected according to the jointly agreed-upon specifications. Retroactive BDD versus shifting left. While it's possible to write scenarios for existing features, retroactive BDD, the highest value comes from applying BDD as early as possible in the development lifecycle. This is often referred to as shifting left, moving quality and clarity to the beginning of the process. Defining behaviors before coding ensures that everyone builds the right thing from the start, significantly reducing rework. 5.2. Facilitating BDD workshops, a step-by-step guide. Effective BDD workshops are the crucible where shared understanding is forged. Facilitating these sessions requires preparation, active guidance, and clear follow-up. Step-by-step workshop facilitation. Preparation before the workshop. Identify stakeholders. Ensure all three amigos and potentially other key stakeholders like design or security experts are available and committed to attending. Define scope. Clearly state which user story, feature, or business problem will be the focus of the workshop. Share the initial story description beforehand. Gather initial ideas. Briefly review existing documentation or preliminary thoughts on the feature to provide a starting point. Prepare tools. Have a whiteboard, sticky notes, different colors for rules, examples, questions, markers, or a virtual collaborative tool ready. During the workshop, execution. Set the stage, 5 to 10 min, reiterate the goal of the workshop. to collaboratively define the behavior of the feature through concrete examples. Explain the BDD given, when, then structure and the example mapping technique if participants are new. Establish ground rules, e.g., active listening, no jargon, focus on one topic at a time. Introduce the story problem, 10 to 15 min. The product owner or business analyst explains the user story or business problem from their perspective, focusing on the why and what. Brainstorm rules behaviors, 20 to 30 min. Start by identifying the main business rules or acceptance criteria associated with the story. Write each rule prominently, e.g., on a yellow sticky note. Encourage all participants to contribute. Generate examples, 30 to 60 min. For each rule, collaboratively generate concrete given, when, then scenarios. The facilitator guides the conversation, prompting for specific details, edge cases, and alternative flows. As examples are created, write them on blue sticky notes and place them under the relevant rule. Capture questions, ongoing. Whenever ambiguity, a missing detail, or a potential edge case arises that cannot be resolved immediately, write it down as a question, pink sticky note. Assign an owner to each question who will seek an answer outside the workshop. These questions are crucial. They represent unearthed risks or missing information. Review and refine, 15 to 20 min. As a group, review all generated rules, examples, and questions. Check for clarity, completeness, and consistency. Read the scenarios aloud to ensure they flow naturally. Prioritize which questions must be answered before development can proceed. Post-workshop, follow-up. Summarize decisions. Circulate a summary of the workshop's outcomes, including all approved scenarios and outstanding questions. Capture scenarios. Formally write the agreed-upon scenarios into feature files, e.g., feature files for Cucumber spec flow. These become the executable specifications. Ensure follow-up. Track the answers to the outstanding questions and update the scenarios accordingly. 5.3. Structuring your features and scenarios for clarity. How you organize your feature files and scenarios can significantly impact maintainability and readability, especially as your project grows. Organize by feature area module. A common and effective approach is to group related feature files within directories that reflect your application's modular or functional areas, e.g., features/user management, features checkout, features/admin dashboard. Clear naming conventions, feature files. Name them intuitively, reflecting the feature they describe, e.g., user registration feature, product search feature. Scenarios. Give scenarios descriptive and unique names that clearly indicate the behavior being tested, e.g., successful user registration. User registers with existing email. Guest user completes checkout. Use tags for granularity. Most BDD frameworks support tags. These are invaluable for organizing, filtering, and running specific subsets of your scenarios. Example tag uses, at smoke or at critical, for scenarios that must pass for a basic build to be considered stable. At regression, to mark scenarios that are part of the full regression suite. At loginflow, to group all scenarios related to login. At integration TWI, to differentiate from simpler functional tests. At WIP, work in progress, to temporarily mark scenarios currently being worked on. This allows you to run Cucumber tags at smoke or SpecFlow run tags loginflow, tailoring your test execution to your immediate needs. 5.4 From user story to scenarios. The process of transforming a user story into concrete BDD scenarios is a continuous refinement. A user story typically describes a high-level capability from the user's perspective. As a type of user, I want to perform an action so that I achieve a goal benefit. BDD takes this abstract desire and breaks it down into tangible, testable examples. Example transformation, user story. As an online shopper, I want to be able to add products to a shopping cart so that I can purchase them later. BDD scenarios derived during a 3 Amigos session. Rule 1, adding a single new product. Scenario, adding a product to an empty cart. Given the user is on the product page, for example lamp, and their shopping cart is empty. When they click the Add to Cart button, then example lamp should be added to their shopping cart, and the cart icon should display one item, and the total price should be $30.99. Scenario, adding a product to a cart that already contains other items. Given the user is on the product page for new item, and their shopping cart contains old item, when they click the Add to Cart button, then new item should be added to their shopping cart, and the cart icon should display 2 items, and the total price should be the sum of new item and old item. Rule 2. Adding the same product multiple times. Scenario: incrementing quantity when adding an existing item again. Given the user's shopping cart contains example lamp, quantity 1. When they click the Add to Cart button for example lamp, then example lamp, quantity in the cart should be 2, and the cart icon should display 2 items, and the total price should be twice the price of example lamp. Rule 3. Handling out-of-stock items. Scenario: user tries to add an out-of-stock product to cart. Given the user is on the product page for limited edition mug, and limited edition mug is out of stock. When they click the Add to Cart button, then an error message, "This item is currently out of stock," should be displayed, and limited edition mug should not be added to the shopping cart. This process ensures that the broad statement of a user story is thoroughly explored, and all necessary behaviors, including edge cases, are identified and captured as testable, executable examples. 5.5 When not to use BDD, or where it's less effective. While BDD is incredibly versatile and powerful, it's not a silver bullet, nor is it appropriate for every testing context. Understanding its boundaries helps optimize your testing strategy. Unit testing. BDD is too high-level for unit tests. Unit tests focus on the smallest atomic units of code, verifying methods and classes in isolation. While TDD, test-driven development, is often used at this level and shares similar red-green refactor cycles, BDD is explicitly about behavioral specifications, not implementation details. Performance testing. BDD scenarios, by their nature, focus on functional behavior. While you can measure scenario execution time, BDD frameworks are not designed for load testing, stress testing, or in-depth performance analysis. Specialized performance testing tools are needed for this. Security testing. While BDD can help define security behaviors, e.g., then unauthorized user cannot access admin page, it's not a tool for penetration testing, vulnerability scanning, or complex security audits. These require specialized security tools and expertise. Exploratory testing. BDD scenarios represent known, expected behaviors. Exploratory testing, by contrast, is an unscripted, investigative approach to discovering unknown bugs or areas for improvement. While BDD provides a solid baseline for what should work, exploratory testing helps uncover what might break or what wasn't thought of. Low-level technical components. If you have internal services or technical components that don't directly expose a business behavior or user interaction, writing Gherkin scenarios might be overkill or force artificial business context. Legacy systems with no existing test framework. While eventually beneficial, retrofitting BDD automation onto a large, complex legacy system with no existing test infrastructure can be a massive undertaking. The initial investment in cleaning up the code, making it testable, and building step definitions can be prohibitive. It's often better to start with new features or gradual refactoring. Practical application. Use BDD for defining and verifying user-facing features, business rules, and critical end-to-end flows, where communication and shared understanding are paramount. Complement it with other testing techniques to cover different aspects of quality. By thoughtfully integrating BDD into your existing workflows, facilitating effective collaborative sessions, structuring your scenarios logically, and understanding its appropriate scope, you can harness its power to build better software and foster a culture of clarity and quality within your team. Common pitfalls and how to avoid them. As powerful and beneficial as behavior-driven development can be, its successful adoption is not guaranteed merely by understanding its principles. Like any significant change in development practice, BDD comes with its own set of common challenges and anti-patterns that can derail even the most well-intentioned teams. This chapter explores these pitfalls and, more importantly, provides practical advice on how to recognize, avoid, and overcome them. 6.1 Scenario Anti-Patterns. The test case trap. One of the most frequent and detrimental mistakes teams make when adopting BDD is treating given, When, then scenarios merely as glorified traditional test cases. This leads to scenarios that are overly technical, implementation-focused, and fail to capture the true intent of BDD. The problem? Too many steps. Scenarios become long, linear scripts that outline every click and keystroke, rather than focusing on a single behavior. Focus on UI details. Instead of describing what the system does, scenarios detail how a user interacts with the UI, e.g., click button with ID equals submit order button. Enter John Doe into text field name equals customer name. This makes them brittle and tied to implementation. Imperative versus declarative style. Imperative describes how to achieve a behavior, e.g., given I navigate to the login page when I type user into username field and I type pass into password field and I click login button. This is a script. Declarative describes what the behavior is, focusing on the outcome, e.g., given I am logged in. This is a specification. Why it's a pitfall, brittle tests. Changes to the UI or underlying implementation cause scenarios to break constantly, leading to high maintenance overhead. Poor readability. Non-technical stakeholders cannot understand these technical scripts, defeating the purpose of ubiquitous language. Not business-focused. The focus shifts from desired behavior and business value to low-level interaction details, losing sight of the why. How to avoid? Focus on outcomes, not steps. Ask what should happen, rather than what steps do I take. Use abstraction. Hide implementation details within step definitions. For instance, instead of when I type username into login field and password into password field, use when I enter valid login credentials. The step definition will handle the specifics. Review for business language. Actively involve non-technical team members in scenario review. If they can't understand it without technical translation, it's too imperative. Keep scenarios concise. If a scenario gets too long, it might be testing too much. Break it down into smaller, more focused scenarios, or consider if some steps belong in a background. Bad example, scenario. User logs in successfully. Given I open the browser, and I go to www.example.com/login. When I type muser into the username input field, and I type mypes into the password input field, and I click the login button, then I should see the welcome message panel displaying welcome, muser, and the URL should be www.example.com/dashboard. Good example, declarative and abstract. Scenario, valid user can log in. Given I am on the login page, when I log in with valid credentials, then I should see a welcome message, and I should be on the dashboard page. The login with valid credentials step definition encapsulates all UI interaction details. 6.2 The automation churn. Brittle tests and maintenance nightmares. Related to the test case trap is the problem of brittle and flaky automated tests. When tests fail constantly, not because of bugs in the software, but due to issues in the automation itself, trust in the test suite erodes and team productivity suffers. The problem? Flaky tests. Tests that pass sometimes and fail other times, even when the underlying application code hasn't changed. High maintenance. Constantly having to update step definitions because of minor UI changes, data issues, or environmental instability. Slow execution. Test suites that take hours to run, delaying feedback. Why it's a pitfall? Lost trust. Teams stop trusting the test suite, leading to ignoring failures or even disabling tests. Increased manual effort. If automated tests are unreliable, teams often resort to time-consuming manual testing. Reduced development velocity. Developers spend more time fixing tests than writing new features. How to avoid? Robust step definitions. Stable locators. Use unique HTML IDs or robust selectors that are less likely to change. Avoid relying on fragile XPath or CSS paths. Page object model or similar patterns. Encapsulate UI interactions within dedicated classes, separating actions from locators. This means if a UI element changes, you only update one place. Clear separation of concerns. Step definitions should orchestrate actions, not contain all low-level logic. Data management. Use test data wisely. Avoid hard-coding data. Use factories or test data generators for more dynamic and realistic scenarios. Ensure tests are isolated and don't interfere with each other's data. Environmental stability. Ensure test environments are consistent and reliable. Flakiness can often stem from network issues, third-party service dependencies, or inconsistent data. Parallel execution. If tests become slow, explore running them in parallel to speed up feedback. Regular review and refactoring of test code. Treat your test automation code with the same discipline as your production code. Refactor it regularly to keep it clean and maintainable. 6.3 Lack of ownership and collaboration breakdown. BDD is fundamentally about collaboration. When communication breaks down or ownership of the BDD process isn't shared across the three amigos, the initiative is likely to fail. The problem? BDD is QA's job. QE or QA engineers are left to write all scenarios and automate them, often interpreting requirements without direct business input, leading to a disconnect. BAs just write documents. Business analysts write scenarios in isolation, handing them off to development without ongoing collaboration. Developer resistance. Developers see BDD as an extra burden or just more testing, rather than a tool for clearer requirements and better design. Lack of management buy-in. Without leadership support, teams struggle to dedicate the time for collaborative workshops and BDD training. Why it's a pitfall? Missed opportunities. The very purpose of BDD, shared understanding, is undermined. Poor quality scenarios. Scenarios might lack business relevance, no business input, be untestable, no QA input, or be technically unfeasible, no developer input. Resentment. A sense of added overhead rather than shared benefit. How to avoid? Mandate 3 amigos sessions. Make collaborative workshops a non-negotiable part of your workflow. Shared responsibility. Emphasize that quality and defining behavior for quality is everyone's responsibility. Train and educate. Provide training on BDD principles for all roles, not just testers. Highlight the benefits for each role. Lead by example. Managers and team leads should actively participate in and champion BDD practices. Celebrate successes. Showcase how BDD helped avoid a costly bug or clarified a complex feature. 6.4 The tool-first mentality. Some teams mistakenly believe that adopting BDD is simply about installing Cucumber, SpecFlow, or Behave. They jump straight into tooling without grasping the underlying principles. The problem? Teams spend excessive time configuring tools before understanding why they use them. BDD becomes a technical exercise rather than a communication practice. Gherkin scenarios are written poorly because the emphasis is not on collaborative behavior definition. Why it's a pitfall? Ineffective adoption. If the communication and collaboration aspects are missed, the tools alone provide little value. Frustration. Teams get bogged down in technical hurdles without seeing the larger picture benefits. How to avoid? Prioritize principles over tools. Start by practicing collaborative discovery and writing Gherkin scenarios, even on paper, before automating anything. Learn the why. Ensure all team members understand why BDD is beneficial, not just how to use the tools. Start small. Don't try to automate everything at once. Pick 1 or 2 critical features, define their behavior collaboratively, and then bring in the tools. 6.5 Not defining a ubiquitous language. Failing to establish and consistently use a ubiquitous language can lead to continued miscommunication, despite using BDD. The problem, different terms used by business versus technical teams, e.g., customer, client, user. Ambiguous terms, e.g., successful transaction. What does successful mean in this context? Domain concepts lacking clear, shared definitions. Why it's a pitfall? Scenarios become ambiguous. Even though Gherkin is plain language, if the language itself isn't consistent, the scenarios can be misinterpreted. Confusion and rework. Team members still operate with different mental models, leading to errors in implementation or testing. How to avoid? Create a domain glossary. Maintain a living document, even a simple Confluence page or wiki, of key business terms and their definitions, agreed upon by the 3 amigos. Regularly review terminology. During workshops, actively challenge ambiguous terms and collectively agree on precise definitions. Enforce consistency. Encourage everyone to use the agreed-upon terms consistently in all documentation, conversations, and code. 6.6 The peril of too much detail, or too little. Finding the right level of abstraction in BDD scenarios is a continuous balancing act. Too much detail makes them brittle, too little makes them unhelpful. The problem: too much detail. Scenarios become a step-by-step UI script, see test case trap. Too little detail. Scenarios are too vague and don't provide sufficient examples to guide development or ensure testability, e.g., given a user tries to log in, then they are handled correctly. Why it's a pitfall: if too detailed, brittle, unreadable, high maintenance. If too vague, misinterpretation, developers building the wrong thing, difficult to automate, poor coverage. How to avoid: focus on business value per scenario. Each scenario should describe a distinct business behavior, not a technical implementation. Use example mapping. The questions generated during example mapping highlight areas where more detail is needed, forcing clarification. Iterate and refine. Scenarios are living documentation. They can and should be refined as understanding evolves. Don't aim for perfection in the first draft, aim for clarity and shared understanding. Ask, what do we need to know to test this? If developers or testers still have questions after reading a scenario, it likely needs more detail. If they feel like it's telling them how to implement, it has too much detail. By proactively addressing these common pitfalls, your team can avoid many of the frustrations associated with BDD adoption and truly unlock its potential for improved communication, collaboration, and high-quality software delivery. Remember, BDD is a journey of continuous improvement, and learning from mistakes is an integral part of that process. Scaling BDD beyond a single team. We've explored how BDD can profoundly impact a single development team, fostering clarity, collaboration, and quality. But what happens when your organization grows beyond one or two teams? How do you maintain the benefits of BDD at scale, across multiple teams, departments, or even diverse product lines? Scaling BDD presents its own unique set of challenges and opportunities, requiring thoughtful strategies to ensure consistency, shared understanding, and efficient delivery across the enterprise. 7.1 BDD across multiple teams or departments. When multiple teams contribute to a larger product or a suite of interconnected services, maintaining a unified approach to BDD becomes crucial. Without a deliberate strategy, each team might develop its own isolated BDD practices, leading to inconsistencies, redundant efforts, and a fragmented understanding of the overall system's behavior. Challenges at scale. Inconsistent language. Different teams might use different terminology for the same domain concepts, eroding the principle of a ubiquitous language across the broader organization. Duplicated effort. Multiple teams might write scenarios for similar functionalities or re-implement shared step definitions without realizing it. Fragmented understanding. It becomes difficult to see the big picture of how different components or features interact, leading to gaps or overlaps in behavioral specifications. Dependency management. If one team's feature relies on another team's service, how do their BDD scenarios integrate? Strategies for alignment. Centralized domain glossary. Beyond a team-specific glossary, establish and maintain an organizational-level glossary of key business terms. This ensures a consistent, ubiquitous language across all teams. Appoint a language guardian or a cross-functional governance group to review and approve new terms. Cross-team 3 Amigos sessions. For features or services that span multiple teams, organize joint 3 Amigos sessions. Ensure representatives from each affected team are present to collaborate on scenarios that touch their respective domains. Shared BDD principles and practices. Document and disseminate best practices for writing Gherkin scenarios and step definitions. This can include style guides, naming conventions, and guidelines for abstracting technical details. Community of practice, COPI. Establish a BDD community of practice where BAs, QAs, and developers from different teams can share experiences, discuss challenges, and collectively evolve their BDD practices. This fosters organic learning and alignment. 7.2 Centralized feature repositories and living documentation at scale. Just as individual feature files serve as living documentation for a single team, a well-managed collection of these files can provide a comprehensive, up-to-date view of the entire system's functionality. Approaches for managing shared Gherkin features. Monorepo versus polyrepo. Monorepo. Storing all feature files and potentially all service code in a single version control repository simplifies discovery and ensures a single source of truth for the entire system's behavior. Changes to Gherkin across different services can be coordinated easily. Polyrepo. If services are in separate repositories, you might need a mechanism to pull relevant feature files into a central location for holistic reporting or to reference scenarios from other services. Dedicated shared feature repository, polyrepo approach. Sometimes, it makes sense to have a separate repository specifically for high-level, end-to-end Gherkin scenarios that describe cross-service business flows. These scenarios would then invoke the underlying services, potentially interacting with their respective component-level BDD tests. Tools for aggregated reporting. Utilize BDD reporting tools that can consolidate results from multiple teams or services into a single, comprehensive dashboard. This allows management and stakeholders to quickly assess the overall health and completeness of the system's behavioral specifications. Web-based living documentation. Consider generating web-based portals from your Gherkin feature files. Tools can parse the Gherkin and present it in an easily navigable and searchable format. This makes it accessible to a wider audience, including product managers, business stakeholders, and even sales teams, reducing reliance on outdated separate documentation. 7.3. Federated BDD automation. When scaling BDD, you're not just scaling scenario writing, but also the automation infrastructure. Each team might own its specific microservice or application, and its BDD tests primarily ensure the behavior of that component. But how do you ensure that these components work together seamlessly in complex, end-to-end flows? Strategies for orchestrating automation at scale. Component-level BDD. Each team focuses on writing BDD scenarios for the behaviors of their own service or component. These tests can run rapidly and provide quick feedback to the owning team. Thin end-to-end scenarios. A dedicated cross-functional team, or even a virtual team composed of representatives from contributing teams, can be responsible for writing a smaller set of high-value, end-to-end BDD scenarios that span multiple services. These scenarios act as integration tests at the business behavior level, verifying critical user journeys across the entire system. API-first approach. For microservices or backend systems, much of the BDD automation can happen at the API layer. This is generally faster and more stable than UI-driven tests. UI-based BDD tests would then focus primarily on the user experience and critical interactions. CI/CD pipeline integration. Integrate BDD automation deeply into your continuous integration, CI, and continuous delivery, CD, pipelines. Component-level tests run frequently on every commit or build for each service. End-to-end tests run less frequently, perhaps nightly or before major deployments, as they are typically slower and more resource-intensive. Deployment gates. Use the passing of critical BDD scenarios as a quality gate before code can be promoted to higher environments, e.g., staging production. Shared test infrastructure. Establish shared testing environments, data management strategies, and potentially common automation libraries frameworks where appropriate. 7.4. Aligning BDD with organizational goals. At an organizational level, BDD is more than just a development practice. It's a strategic enabler. Leaders can leverage BDD to support broader objectives such as improved business agility. Faster feedback loops and clearer understanding enable quicker adaptation to market changes. Reduced risk. Early detection of misinterpretations and defects, leading to fewer costly surprises in production. Client satisfaction, delivering software that precisely meets defined business needs. Regulatory compliance. For heavily regulated industries, BDD scenarios can serve as auditable, executable evidence of compliance with specific business rules. Large-scale transformation. BDD can act as a catalyst for cultural change, fostering collaboration and breaking down silos between business and it. Measuring the impact of BDD adoption at scale. Defect reduction. Is there a noticeable decrease in production defects related to requirements misunderstandings? Reduced rework. Are teams spending less time correcting features that were built wrong? Time to market. Are features delivered faster, from conception to production? Stakeholder satisfaction. Are business stakeholders more confident in the development process and the delivered software? Team morale. Is there an uptick in team satisfaction due to clearer communication and fewer integration headaches? While quantitative metrics are valuable, don't underestimate qualitative observations. Anecdotes, survey results, and direct feedback from teams and business partners can provide rich insights into the success of your BDD scaling efforts. 7.5 Leadership's role in scaling BDD. Successful BDD adoption at scale requires more than just bottom-up enthusiasm from teams. It needs top-down support, championship, and strategic investment from leadership. Executive buy-in. Leaders must understand the strategic value of BDD and actively promote its adoption. This includes allocating resources for training, tools, and dedicated time for collaborative activities. Resource allocation. Provide budget for BDD tools, training workshops, and potentially BDD coaches or experts who can guide teams through the scaling journey. Foster a culture of collaboration. Leadership must actively promote and reward cross-functional collaboration. Break down organizational silos and encourage shared ownership of value delivery. Training and mentorship programs. Invest in comprehensive training programs for all roles involved in BDD, product owners, BAs, developers, QAs. Establish mentorship programs where experienced BDD practitioners can guide newer teams. Lead by example. When leaders participate in discussions, show interest in the BDD reports, and champion the practices, it sends a powerful message to the entire organization. Remove impediments. Identify and eliminate organizational blockers that hinder BDD adoption, such as rigid processes, lack of shared environments, or insufficient time for collaboration. Scaling BDD is not about dictating a uniform process, but about establishing a consistent framework and shared understanding that enables multiple teams to work cohesively towards a common goal. It empowers the organization to deliver high-quality software efficiently, with clarity and confidence, even in complex, multi-team environments. The human element, culture, communication, and continuous improvement. While BDD provides powerful structures, methodologies, and tools, its ultimate success hinges on the human element. At its core, behavior-driven development is about people communicating better, collaborating more effectively, and building shared understanding. Without a supportive culture, open communication channels, and a commitment to continuous improvement, the most perfectly crafted Gherkin scenarios or sophisticated automation frameworks will fall short. This chapter delves into the often underestimated cultural and interpersonal aspects that make BDD truly thrive. 8.1 BDD as a cultural shift. Implementing BDD often requires a significant shift in existing organizational culture. It moves away from traditional, sequential, throw-it-over-the-wall handoffs, where business analysts write requirements, throw them to developers to build, who then throw them to QAs to test, to an integrated, collaborative workflow. From us versus them to we, BDD actively dismantles the historical divide between business and IT, or between development and testing. The Three Amigos concept is not just a meeting structure. It's a philosophy that champions shared ownership and mutual respect for different perspectives. Developers are no longer just coders, they are active participants in defining behavior. Testers are not just bug finders. They are crucial in clarifying requirements. Business folks are not just idea generators, they are responsible for providing clear examples, building trust and psychological safety. For open and honest communication to thrive in BDD workshops, participants must feel safe to ask dumb questions, challenge assumptions, and admit when they don't understand something. A culture of psychological safety encourages experimentation, learning from mistakes, and transparency. Without trust, people may hold back critical information or agree to ideas they don't truly understand, leading to hidden ambiguities. Encouraging experimentation and learning from failure. BDD's red, green refactor cycle is itself a form of experimentation. It encourages teams to try out ideas, see what works, and quickly learn from what doesn't. Failure, e.g., a scenario failing, is seen as a learning opportunity and a rapid feedback mechanism, not a personal indictment. This mindset is crucial for iterative development. 8.2. Mastering facilitation and active listening. The success of BDD workshops and continuous collaboration relies heavily on effective facilitation and the practice of active listening. These are soft skills, but they are absolutely critical for BDD. Effective facilitation, neutral guidance. The facilitator, often a Scrum Master, BA, or experienced team member, acts as a neutral party, guiding the group through the process without imposing solutions. Time management, keeping discussions on track and within agreed-upon time boxes. Encouraging participation, ensuring all voices are heard, especially the quieter ones. Proactively asking individuals for their input. Handling conflict. Mediating disagreements by refocusing on the shared goal and clarifying underlying assumptions. Visualizing information. Using whiteboards, sticky notes, or digital collaboration tools to make discussions tangible and easy to follow. Summarizing and confirming. Periodically pausing to summarize what has been agreed upon, ensuring everyone is on the same page before moving forward. So, to confirm, we're saying that X will happen when Y happens, right? Active listening. This goes beyond just hearing words. It involves paying full attention, giving the speaker your undivided focus. Understanding, not just responding. Listening to comprehend the speaker's message, including their underlying feelings and intent, rather than formulating your rebuttal. Nonverbal cues. Observing body language and other nonverbal signals. Asking clarifying questions. Can you give me an example of that? What do you mean by quickly? Could you elaborate on that point? These questions are vital for uncovering ambiguity and hidden assumptions in BDD discussions. Paraphrasing, repeating back what you heard in your own words to confirm understanding. So, if I understand correctly, you're looking for a notification to be sent to the customer if the order status changes to shipped. Mastering these skills allows teams to truly leverage the collaborative potential of BDD, transforming fuzzy requirements into crystal clear, shared understanding. 8.3 Feedback loops and continuous improvement. BDD itself is a giant feedback loop. The scenarios provide immediate feedback on whether the software behaves as intended. But beyond the technical feedback, BDD fosters human feedback loops critical for continuous improvement. Retrospectives. BDD should be a recurring topic in team retrospectives. Beyond functional improvements, teams should regularly inspect and adapt their BDD practices. Questions for a BDD-focused retrospective. Are our Three Amigos sessions effective? Are all voice heard? Are our Gherkin scenarios clear and concise? Can non-technical people understand them? Are our automated tests reliable? What's causing flakiness? Are we consistently defining a ubiquitous language? When did BDD help us avoid a problem and why? What challenges are we facing with BDD and what can we try next? By regularly reflecting on these questions, teams can identify areas for improvement in their BDD execution, from meeting facilitation to automation strategy. Learning from failures of the process. If a scenario continuously leads to misinterpretations or bugs, it's not just a technical failure, it's a process failure. The team should analyze why the initial discussion didn't lead to a clear, executable specification and adjust their discovery process. Celebrating successes. Acknowledging when BDD practices lead to smoother development, fewer bugs, or clearer communication reinforces positive behaviors and encourages continued adoption. 8.4 Onboarding new team members with BDD. One of the often overlooked cultural benefits of BDD is its power as an onboarding tool. When new team members, whether developers, testers, or product owners, join a BDD-fluent team, they gain an immediate advantage. Self-documenting codebase. Instead of wading through outdated design documents or complex code, new members can start by reading the feature files. The Gherkin scenarios, written in clear, business-oriented language, provide a high-level overview of the system's intended behavior and its key features. Understanding why. The scenarios clearly articulate the why behind features, what problem they solve, and how they are expected to function from a user's perspective. Rapid ramp-up. New developers can quickly understand a module's function by examining its associated BDD features and scenarios. This helps them navigate the codebase, understand the domain, and contribute more quickly. Consistency and standards. Exposure to clear, consistent Gherkin scenarios helps new team members quickly learn the team's standards for defining and documenting behavior. Anecdote. A new developer joined a payment processing team. Traditionally, it would take weeks to understand the complex rules governing different payment methods, currencies, and fraud detection. However, the existing BDD feature files for each payment type, with their given a customer attempts to pay with card type from country. When the payment is processed, then, scenarios allow the new developer to grasp the intricate business logic in days rather than weeks. The tests were the documentation, and they were always up to date. 8.5. Championing BDD within your organization. Successful BDD adoption often starts with passionate individuals or teams who become champions for the practice. Become an advocate. Share your successes, present case studies, and articulate the benefits of BDD to other teams, leaders, and stakeholders. Demonstrate value. Don't just talk about BDD, show it in action. Demonstrate how it reduces rework, clarifies understanding, and leads to higher quality software. Share knowledge. Mentor other teams, offer to facilitate workshops, and share reusable step definitions or best practices. Empathy and patience. Understand that change can be uncomfortable. Address concerns, listen to resistance, and be patient. Introduce BDD incrementally, focusing on building understanding and trust rather than imposing rigid rules. Continuous improvement of the process itself. Like the software it verifies, your BDD adoption process should be subject to continuous improvement. What worked for one team might need adjustment for another. Be flexible and adaptable. The human element is not a side effect of BDD. It is its very essence. By cultivating a culture of collaboration, fostering active communication, practicing continuous improvement, and championing the values of BDD, organizations can unlock its full potential, transforming not just how they build software, but how they work together to deliver value. Your BDD journey, a path to better outcomes. We have journeyed together through the landscape of behavior-driven development, from its fundamental principles and the simple power of given. Then, through the art of collaborative scenario crafting, the bridge to automation, and the critical human element. We've seen how BDD can transform communication, enhance quality, and scale across an organization. This final chapter serves as a recap of our key takeaways, offers practical advice for embarking on your own BDD journey, and looks towards the future of this dynamic approach. 9.1. Recap of key BDD principles. Let's reiterate the core tenets that underscore the power of BDD. BDD is about collaboration and communication first. It's not primarily a testing technique or a tool. It's a method to foster shared understanding between business and technical roles. It forces clear conversations. Ubiquitous language is essential. BDD champions a common vocabulary that everyone involved in the project understands and uses consistently. This eliminates ambiguity and ensures alignment. Given, when, then is your storytelling framework. This natural language structure allows you to describe system behavior concisely, concretely, and from a business perspective. Examples drive understanding. Concrete scenarios and examples are more effective than abstract requirements. They surface assumptions and clarify expectations. Executable specifications provide living documentation. When BDD scenarios are automated, they become a self-validating, always up-to-date source of truth for your system's behavior. BDD is a cultural shift. It requires empathy, active listening, and a willingness to break down silos between roles, fostering psychological safety and shared ownership. Continuous improvement is key. BDD is a journey, not a destination. Regularly inspect and adapt your practices, learning from successes and failures. These principles combine to create a powerful feedback loop, ensuring that what gets built is truly what the business needs, understood by all, and verified continuously. 9.2 First Steps. Getting started with BDD in your team. The ideas presented in this book might seem extensive, but embarking on your BDD journey doesn't require a revolution. Start small, learn fast, and grow organically. Educate your team. Don't just introduce Gherkin syntax. Explain the why behind BDD. Share this book or specific chapters to build a common understanding of the principles. Identify your three amigos. Identify a product owner, business analyst, a developer, and a tester willing to lead the charge. Their enthusiasm and collaboration will be contagious. Start with one feature user story. Pick a contained, new feature or a small, well-understood user story. Don't try to apply BDD to an entire legacy system first. Facilitate a BDD workshop, example mapping. For that chosen feature, run a collaborative workshop. Focus on defining behaviors using concrete examples. Use sticky notes, a whiteboard, or a virtual equivalent. Don't worry about automation yet, master the conversation. Write the Gherkin scenarios. Transcribe the agreed-upon examples into feature files using the given, when, then syntax. Ensure they are readable by everyone. Introduce automation, iterative. Once comfortable with scenario writing, gradually introduce an automation framework, e.g., Cucumber, SpecFlow, Behave. Start by automating just one or two of the simplest scenarios. Focus on writing robust step definitions that abstract away technical details. Integrate test execution into your CI/CD pipeline as soon as possible to get rapid feedback. Hold BDD-focused retrospectives. Regularly discuss how BDD is going. What's working? What's challenging? How can you improve your process? Remember, the goal is to improve communication and deliver better software, not to become a Gherkin guru overnight. Embrace the learning process. 9.3 Measuring success. How will you know BDD is making a difference? Success isn't always measured in lines of code or number of tests. Look for improvements in these areas. Qualitative observations. Reduced misunderstandings. Are there fewer "that's not what I asked for" moments? Increased collaboration. Are business, development, and QA talking more effectively? Greater confidence. Do teams feel more confident in releasing software? Shared understanding. Can everyone articulate what a feature does and why it's important? Smoother onboarding. Are new team members integrating faster due to clear documentation? Quantitative metrics, where applicable. Defect escape rate. Are fewer bugs making it to production, particularly those related to misaligned requirements? Rework reduction. Is less time spent re-implementing features due to incorrect initial understanding? Feature cycle time. While BDD isn't solely about speed, better communication can contribute to faster delivery from idea to deployment. Test suite reliability. Is your automated BDD suite consistently passing, when it should, and providing quick, reliable feedback? Focus on the outcomes that matter most to your organization and team. 9.4 The future of BDD and continuous learning. Behavior-driven development continues to evolve. As software development paradigms shift, e.g., towards highly distributed microservices, AI, ML-driven systems, serverless architectures, BDD will adapt. The core principles of clear communication, collaborative definition of behavior, and executable specifications remain timeless. New tools and techniques emerge regularly to support these principles. Keep an eye on advanced example mapping techniques, how to apply example mapping to increasingly complex domains. Integration with design tools, how to bridge the gap between design systems and BDD scenarios. AI-assisted scenario generation refinement, the potential for AI to help teams generate more comprehensive scenarios or identify ambiguities. Event-driven BDD, applying BDD principles to systems built on events and asynchronous communication. The best way to stay current is to engage with the BDD community. Look for online forums, local meetups, conferences, and open-source projects. Share your experiences, learn from others, and contribute to the collective knowledge. 9.5 Final encouragement. Your BDD journey will have its challenges. You'll encounter resistance, write flaky tests, and perhaps struggle with some complex scenarios. This is normal. The true value of BDD isn't in achieving theoretical perfection, but in the continuous effort to improve how you communicate, how you build, and how you deliver value. BDD is a powerful ally in the quest for creating software that genuinely meets needs, delights users, and fosters clarity within teams. By embracing its collaborative heart, leveraging its structured language, and committing to continuous learning, you are not just adopting a new methodology. You are building a more effective, more enjoyable, and ultimately more successful path to better software. Start today. Pick a single feature, gather your amigos, and begin the conversation. The path to better outcomes awaits.